everyone. Once again, I would like to welcome all the viewers, especially the class 10 students, to this online class which is conducted by State Council of Science, Technology and Environment. Today I am going to do you all about the new topic and a very interesting one which is taken from chemistry textbook prescribed by MBOSE for class 10, chapter 4, and the name of the chapter is Classification of Elements. Okay. Alright, to start with the chapter, first I want to know from you all whether you all are aware of the differences between mixtures, compounds and elements. Right. Mixtures, they are like food items that we consume. They contain everything in proportion that we desire. We can add or we remove. Right. That is about mixture. On the other hand, compounds are those which contain the substances in fixed proportion. If we remove the proportion of the substances, it will affect the compound and will render its changes. For instance, if you remove one atom of hydrogen, one atom of H2O, that is water, the composition changes. And H2O as a compound does not form. So fixed proportion is a must in compound. Lastly, we have the elements. Element is the purest form of all the substance that we know, right? And it composed of only the same type of atoms. It does not contain anything in proportion nor random mixing of any substances. So we can say that compounds is a mixture of the elements. Now, it means that elements is the basic form of all the materials that we can find around us, right? So in order to study the elements, first we need to study the various materials, the various substances. First, we need to begin with studying the various elements. Now, I want to ask a question. Do you know how many elements that exist? Yes, the elements that exist naturally is 98 and the elements known to mankind is 180. Elements that exist naturally is 98 and known to mankind is 180. Right. Another question. Do you think it is possible for us to study each element individually for all its properties? By looking at the number of elements that exist, I don't think that would be possible for us to study all the properties of all the elements. So in order to study all the properties of the elements, first we need to organize them. Right? First we need to organize them. And then after organize the element appropriately, then this organization will be helpful by using an arrangement. Yes, when you arrange the various elements, it will help us in order to understand the different properties of elements. Let's say after organize, you need to arrange the elements. And this arrangement is possible only if we categorize them. So after that, you need to categorize the element. So this method of categorization of the elements will help us to study the elements at ease. In other words, we can say that we have classified the elements. Alright, so classification of elements is categorizing the elements into groups based on the similarities of their physical and chemical properties. We will do now classification of elements. Classification of elements. First, based on the similarities of their physical and chemical properties. Also, classification of elements helps us in grouping the elements into categories which we refer to as a period. So this whole system of classification is known as a periodic classification of elements. Whole system is known as a periodic classification of elements. Now, there are many scientists who have studied on how to classify the elements. So, now let us see how classification of elements was carried in the olden days where not many elements were known at that time. The first attempt to classify the elements was done by German scientist Johann Wolfgang Lubrener in 1870. The first attempt was done by Johann Wolfgang Lubrener. Alright, he is a German scientist in the year 1870. So the famous of this work is known as Lubrener's triad. His famous work is known as Lubrener's triads. Right? So here the word triads means a group of three. So Lubrener formed a triad for some elements. Let's say the first triad that he made is lithium, sodium and potassium. The first triad made by Lubrener is lithium, Li, sodium, Na, and then potassium, A. Alright, all these three elements, they have the same physical and chemical properties. And also here lithium, sodium and potassium are metals. All these three can react with water in order to form alkalis and hydrogen gas. Another important thing here, all these three elements have valency 1. Alright, now the special thing about the Lubrener's triad is that he stated that the elements in the triad can be arranged, in the order of their increasing atomic masses. So here, looking from here, the atomic mass of lithium is 7, sodium is 23 and potassium is 39. In this way, he arranged the elements in the order of their increasing atomic mass. That is the first special thing about Lubrener's triad. The second thing is that he stated that the atomic mass of the second element is approximately equal to the arithmetic mean of the two elements. Alright, for your understanding, let's see here. Arithmetic mean of 7 and 39. So this we have 46, then which is 23. So we can clearly see from here that this 23 is the atomic mass of the second element, that is sodium. So Lubrener gives some more triads in his work, that is, we have the first one is, another one, calcium, strontium and barium with atomic mass 40, 88, 137. Another triads, we have chlorine, bromine, iodine with atomic mass here is 35.5, 80 and 127. Right, these two are another triads made by Lubrener. From here also, these two triads have the same physical and chemical properties, and they are also arranged in an increasing order of their atomic masses. Also, the atomic mass of the second element will be approximately equal to the average of the other two elements. Alright, but the Berenius could identify only these three triads from the elements known at that time. So his classification was not so successful. Now let us see to the second attempt made by another scientist. Alright, the second attempt to classify the elements was proposed by an English scientist, John Newlands, in 1864. John Newlands. Here's an English scientist. In 1864. The famous name of his work is known as Newlands' Law of Octaves. His work is known as Newlands' Law of Octaves. It states that when the elements are arranged in the order of their increasing atomic mass, the properties of the eighth element is the same as that of the first element. Alright, he stated that when the elements are arranged, in the order of their increasing atomic masses, right? What happened? The eighth element properties of eighth element is the same as the properties of the first element. Alright. Here, the word octaves is inspired from music. In case of octaves, every eighth note is the same as that of the first note. Similarly, Newland observed that when he arranged the elements in the order of their increasing atomic mass, he observed that these elements have similar chemical properties, where the eighth element have the same properties as that of the first element, and then the ninth element with that of the second element, and so on. Alright, you can see from this table, this is Newland's table. So these elements here are arranged in the order of their increasing atomic mass. And according to his statement, he stated that the eighth element have the same property as that of the first element. So here, let us concentrate on lithium. If we concentrate on lithium, start counting from lithium. 1, 2, 3, 4, 5, 6, 7, 8. So the eighth element here is sodium. According to the statement of Newland's law, it states that here in this case, lithium and sodium will have the same properties. So similarly, it means that beryllium and magnesium will have the same properties. Boron and aluminium will have the same properties, and in this way you can check the same thing. Alright. So on observing that, still Newland's work does not hold for every element. So there are some issues on Newland's law of octaves. So let us see some of the issues of Newland's law of octaves. The first issue will be that the Newland's law of octaves is valid only till calcium. Alright. So after calcium, the eighth element does not have the same property as that of the first element. So it valids only till calcium. It valid only till calcium. And then the second issue is that Newland assumed that there were only 56 elements. But later, when more elements were discovered, those elements has properties which are different from the elements in his table. So those elements cannot fit into Newton's table. The second property is that he assumed that only 56 elements that exist. Alright? And now the third property you can see from this table. So the third issue is that you can see in this first period, in this first group, in order to fit the element in the table, what happened? Newton, he even put two elements at one slot. Like you can see from here, cobalt and nickel is put in the same slot. Alright. And then when we see the elements in this group, fluorine, chlorine and bromine, and then we can see that cobalt and nickel lies in the same group with fluorine, chlorine and bromine, whose properties are totally different from that of cobalt and nickel. The third issue is that cobalt and nickel, they are put in the same slot. In the same slot. Right. So it means here that Newton's law of octaves is valid only for the lighter elements, that is still calcium. So these two are the atoms made by those scientists, and in the next class we will see the next atom, alright, which is called as the Mendeleev periodic table. So until then, stay safe, take care.